Alright, this is separation of variables 2 for AB Calculus. Same directions as every other one you've seen so far. Find the general solution y equals f of x to the differential equation. This says y prime equals 2xy. Well, what do we mean by y prime? We mean the derivative of y with respect to x. So that's just rewriting that here because when we do separation of variables, you will see that thinking of things in dy's and dx's is much easier than thinking of things in terms of primes. And so that is one of the many benefits of using Leibniz notation, which is the dy and dx rather than the f primes, because it makes solving differential equations a lot easier. Alright, so how do we do this? We need to get the y's and the x's on both sides because we're not doing multivariable calculus. And so usually, in this case, this can be done just by doing that, by multiplying this dx over this way, like so. Multiplying that dx over and dividing that dy down here. So the dx and the y are switching places. And so you get dy over y equals 2x dx. Alright, so before we had always just ended up with dy equals something dx. But now we have dy over y, and so these differential equations are going to require a little more work to resolve into a function of x later on. But what we can do, we can still integrate both sides. Oh, and he's just showing in that animated fashion that you still only have y's here and you only have x's there. Integrating both sides yields that. The integral of 1 over y dy, or dy over y, you'll sometimes see it written if you just bump that dy up to the one of this, is ln of the absolute value of x. Y in this case, sorry. And this one is x squared, just bringing that 2 up. And we're adding this arbitrary constant. Well, this is great and all, but it's asking us for this is a function of x. If I give you an x, it's not very clear what the y is, and so we're going to need to manipulate this a little bit. And so what you do is you take e to both sides, and this might seem kind of odd, but I'll give a little more elaboration here. E to the ln of y, of absolute value of y, is the absolute value of y. And the reason that is, another way you can think of this, like, let's see here. If I say that the natural log of a equals b, then that means, what that means is that, let's see, make sure I get this right, means that e to the power of b equals a. So, we have this base e here, so we're taking e to the b, and that's what gives us our inside. And so what we do in logarithms, it's saying e to the what gives me a. And so you can almost think of it like this too. E to the what, and that what is here, e to the x squared plus c gives me the absolute value of y. And so that's how that kind of works out. Super important that the constant is moved into the exponent. So again, you can visualize this either as taking e to the e as the base of an exponent of both sides, which is something you don't normally do, but if e to the blob, if two blobs are equal to each other, then e to those blobs are going to be equal to each other too. I mean, I guess that's intuitive enough. But that constant has to be up into the exponent because you can almost put parentheses around those just to remind you that you're not adding c anymore. You're taking it to the power. All right, we all know from Algebra 1 or 7th grade or something that x squared times x cubed is x to the 5th. And what you're doing is adding those exponents. And so as a result, e to the x squared plus c, all in that power, has to be equal to the e to the x squared times e to the c, and if you were to simplify that, you could say e to the x squared plus c, but in this case, it turns out to be a simplification to, it turns out to be kind of a simplification to, bring it back into this form, because e to a constant is just another constant, right? And so, because of that, you can say e to a constant is just another constant, and we're going to call that c sub 2. So it's another constant, but it's distinctly different from this one. Maybe it's the same if it's like 1 or something, but you can't count on that. So you call it another constant c sub 2, but plus or minus, and this plus or minus is actually here from the square root of y over here, because either a plus or a minus would give you that result, so you're covering yourself. But plus or minus a constant is just another constant, and so we're going to call that c sub 3 instead. And this is your explicit solution, y equals f of x, to this differential equation. And if you want to check your results with respect to x of both sides, dy dx equals c sub 3 times e to the x squared times 2x. Now, this is interesting because, here we thought that dy dx is equal to 2xy, but dy dx is also equal to this thing. And so, just as a little warning, in this case, it might not be the best idea to try and confirm your correctness in this way, because otherwise you're going to think you're wrong, and you're not. But I assure you these are the same thing, or at least they give the same solution. Okay, now we have some pluses and minuses here, but what we're going to do is try and isolate that y prime. Okay, just turning that into dy dx. We're going to try and isolate that dy dx. Dy dx equals xy minus 5x. Now we can factor out this x here and get that. And shifting stuff around and integrating gives you that. And the whole purpose of all of this, all of this, process going through here might have seemed, kind of like, well, what are you doing? Why are you doing that? But the whole purpose is to try to get separate variables so that you have all y's here, both y's and dy's, and all x's there, because otherwise you can't integrate. So whatever you need to do, shifting stuff around, usually rewriting as dy dx as opposed to that y prime is a good idea. And if you're ever having things that are subtracted and added to each other, at least in this class, chances are you're going to have something factor, because otherwise it's going to be very difficult to separate variables. So going through the integration process, ln of absolute value of y minus 5 equals 1/2 x squared plus c. Taking e to both powers, or thinking that y minus 5 to the that thing power must equal y minus 5 is, e to the that thing power must equal y minus 5 is also a perfectly valid way of looking at it. And so then that e and the ln kind of cancel each other out, not in the traditional sense, but you're left with y minus 5, or at least its absolute value. E to the c, that's just another constant, so we call it c sub 2. And we got rid of those absolute values because it's just implied that you can take care of it with this other constant here. And, you can adjust that constant, positive or negative, to suit your needs. And adding 5 over gives you y equals blob with x's in it, which is what f of x truly means. And that's your solution. One more. So we're going to rewrite this, y dy dx. Oh, okay, so there was some simplification that went on here. I'll just write this out how it happened. Y dy dx equals 4 cosine of 3x Then multiplying that dx over gives you y dy equals 4 cosine of 3x dx, and that brings us to here where we integrate. Doing some subbing for this trig one over here gives us that. This should be pretty, trivial for you at this point, but if it's not, just go back and review. It's okay. Integrating 1/2 y squared equals that thing plus c. Now the interesting thing here, and he points this out, this is your solution, just multiplying 2 over, and when you multiply, you turn that into an 8, and this constant, when you multiply it by 2, just turns into another constant, which we, distinguish as different, like so. But the directions do not say to solve for y explicitly. Before it said to solve for a solution y equals f of x. We kept seeing that, y equals f of x, y equals f of x. But it does not say it here. And so that means that you don't have to have y equals something full of x's. You can leave it like this. And the benefit of that is that, if you didn't, you'd have to say y equals plus or minus the square root of 8 over 3 sine of 3x plus c2. And then it's hard to solve for your constant, and to solve anything, you're probably just going to have to square both sides anyways, and then you got that awkward, plus or minus there, all just to get that y alone. And so it's probably not worth it, and when the directions don't say to solve for y equals f of x, you don't. And the book will give it to you like that, as stated by this unnecessarily large rectangle. So hopefully that was helpful for solving these differential equations, and I'll see you in part 3.